now that we've learned how to find regression lines for data that looks and we've determined has a strong linear relationship, now we're going to talk about the coefficient of determination, different types of variation, and some things that we can use our regression model, some questions we can answer, some information we can find from that. So when we made our equation of our regression line, we said y prime is equal to a plus bx. So y prime is our, what I'm going to call our predicted values. They are the points that are on this line that we created. When we talk about plain old y, those are our observed values. There's going to be a lot of y's here, so I want to make sure before we even start talking about definitions that we can keep our y's straight. Okay. When we talk about y bar, we know that that is our mean, and it's the mean of the observed values. Okay. So regular y is observed, y bar is our mean, and y prime is our predicted value from our regression line. When we talk about variation, if I want to talk about the total variation of my data, if we're comparing distances from this regression line, whether it's our observed distances or maybe we want to know our distance away from the mean values, we will be talking about variation. And the total variation is the sum of the squares of the differences between y and y bar. So y being the observed values that we saw, y bar meaning the mean of those, and if we square them and then add them up, that's our total variation. We can talk about our total variation has some more breakdown. We have our explained variation, and the explained variation is the sum of the squares of the difference between the predicted value and the mean. Okay, that's our explained variation. The closer the r is to 1 or -1, then these two values become closer and closer together, meaning the part of our variation that we can explain is very close to our total variation. So the closer r is to 1 or -1, these two guys become closer and closer together. When we talk unexplained variation, that's the variation that's due to chance, something that we can't explain by definition. And that's the sum of the squares of the differences between the observed value and the predicted value. All of these, once we find the difference, we're going to square them. Because some of them, when some values are positive and some are negative, if we just looked at that sum of the differences, then that doesn't give us a very good picture. So the smaller this is, again, the closer to 1 or -1 r is. As r approaches 1 or -1, our explained variation gets very close to the total variation, which means our unexplained gets smaller. Okay, the total variation is the sum of the explained variation plus the unexplained. If we add up these two variations, we get the total. All right. So I want to go back for a minute for several minutes, to this example that we've done on our other videos. We had the amount of money that a person makes, the amount of dollars that they spend per month on recreation, We agreed that it had a linear relationship that was strong enough to write the regression line, and here is our regression line. Okay, I don't know if I him down here. If I can get these guys to show side by side a little bit. But I have put my x values and my y values there. If we're going to start finding the variations, the total variation, the explained variation, the unexplained variation, then we can use Excel to help us find the values that we need. Okay, one of those values that we need is the y bar, okay, our mean. So if we add up the y's and divide by 7, our y bar is going to be, or our mean of our observed y's is going to be 120. So another column we're going to need, oops, let's highlight the whole column, is y minus y bar, meaning our observed value minus 120. So I take 60 minus 120, 200 minus 120, 160 minus 120, and so on down the line. Okay, please notice that the sum of my differences there is 0, and that should always be the case. The difference between your value and the mean, if you add all those up, that will always zero out if you've done things correctly. Okay. What we really need in our formula, though, is we need to square these values. Now, you could do that all in one column or all at once in Excel if you know how to do that. Please feel free to do that, but I wanted to just work it out baby steps, one column at a time. So once we have all of our y minus y bars, then we're going to need to square them. Something else we need to find is our predicted value of y, our y prime. And the y prime is something we get from our regression line that we found in the other video. So what that means is I'm going to plug 800 into this equation for x and 1200 into that equation for x, and so on down the line, getting those values out. Now, I did this one time rounding to 61.5, and then I did it one time leaving it exactly the way I have it in my calculator, which since these guys were to 3 decimal places, these guys came out to 3 decimal places, and we don't need a sum there. And we're not going to get a perfectly exact, outcome for this. So for our variation, but I still wanted to show you, kind of walk you through the process, even though it's not going to be perfect. So the rounding, we're going to either get an overestimate or underestimate depending on how we round here. Something else we need is y prime minus y bar. So we'll take our 61.5 minus 120. Okay, and do that on down the line. You can either recreate this on your own or you can pause the video and write these down as we go, but I'm not going to hesitate very long in these. But we also, once we have those differences, we need to square them. I just wrote squared instead of all that Junko squared. So here are the squared values from column G. We also need our observed values y minus y bar. So I made a column there, and we're going to get to square them also. And I have sums where we need to have sums. Hop across here for just a minute. Before I put this back, and actually it's going to disappear again for a minute. If I want the total variation, which is the sum of the y minus y bar squareds. From my Excel spreadsheet, my y minus y bar squareds is 19,250. If we want to talk about our explained variation, the explained variation is the sum of y prime minus y bar, that quantity squared. which is this value right here, the 15,465. I'm just going to round it to 15,465. Our unexplained variation is the sum of, I just lost it with my eyes, the y minus y prime squared. So y minus y prime squared is, I'm going to call that 3802. Now, again, in theory, if we add the two bottom values up, they should equal the top value. And here, close-ish, but not super great. Again, I tried this 2 or 3 times at home, rounding to different values, and I never did get it to be perfect. So I don't know whether I mistyped something when I was copying stuff into my table. If you find an error, please let me know. But again, in theory, those two bottom numbers should add up to the top one. We're not perfect due to rounding, or maybe a rounding issue over here. But this shows you what we're after. Okay. Come back for the next video to learn more.